myself, Dr. Dinesh Kumar, lecturer physics, Government Victoria Girls Senior Secondary School, Patiala. ਅੱਜ ਜਿਹੜਾ ਮੇਰਾ ਟੌਪਿਕ ਹੈ ਉਹ ਹੈ ਟਰਾਂਸਫਾਰਮਰ। ਹੁਣ ਟਰਾਂਸਫਾਰਮਰ ਕੀ ਹੁੰਦਾ ਹੈ? Transformer is a device which transforms the electric current from one circuit into another circuit with the same frequency. Or transformer is a device which converts low alternating current at high voltage into high alternating current at low voltage and vice versa. This is one of the diagram of the transformer. Then working principle. It works on the principle of mutual induction. That means when current flowing through a coil or magnetic flux linked with a coil changes, an induced EMF is produced in the other coil. Now, construction and working of the transformer. VP, voltage across the primary. NP, number of turns across the primary. NS, number of turns across the secondary. VS, voltage across the secondary. ਅਸੀਂ ਇਨਪੁਟ ਨੂੰ ਪ੍ਰਾਇਮਰੀ ਚ ਦਿੰਨੇ ਆ ਤੇ ਆਊਟਪੁੱਟ ਅਸੀਂ ਸੈਕੰਡਰੀ ਤੋਂ ਲੈਂਦੇ ਆ। A transformer consists of two sets of coil insulated from each other. They are wound on a soft iron core as shown in this figure. One of the coil called primary coil or input coil. The other coil is called secondary coil or the output coil. When an alternating voltage is applied to the primary, the resulting current produces an alternating magnetic flux, ਜਿਹਨੂੰ ਅਸੀਂ phi ਨਾਲ denote ਕਰਦੇ ਹਾਂ, which links with the secondary and induces an EMF in it. Let phi be the magnetic flux in each turn in the core at time t due to the current in the primary coil when an EMF or voltage EP or VP is applied to it. According to Faraday's second law, the induced EMF or voltage ES or VS in the secondary coil with NS turns in the secondary is given by ES is equal to minus NS d phi by dt, according to Faraday law. The alternating flux phi also induced an EMF called back EMF in the primary coil. This is given by EP is equal to VP is equal to minus NP d phi by dt. Mark it number 2. When you divide both the equations from 1 and 2, ES upon EP is equal to VS upon VP is equal to minus NS d phi by dt over minus NP d phi by dt. Minus sign cancel, d phi by dt cancel. ES upon EP is equal to NS upon NP. Yeah, VS upon VP is equal to NS upon NP, called transformation ratio. Ratio of the number of turns in the secondary coil to the primary coil is called transformation ratio. Now, special note, for an ideal transformer, no energy is lost in the process of transformation. So, P output is equal to P input, or VSIS is equal to VPIP. Therefore, transformation ratio is equal to VS upon VP is equal to NS upon NP is equal to IP upon IS. Transformers cannot work with DC voltages since they are based on Faraday laws. A transformer in which number of turns in the secondary are more than number of turns in the primary, voltage across secondary is more than the voltage across the primary, current across the secondary is less than current across the primary. As shown in this figure, it converts low AC voltage into high AC voltage. Then step down transformer in which number of turns in the primary are more than the number of turns in the secondary and the voltage across the primary is greater than the voltage across the secondary and the current in the primary is less than the current across the secondary. It converts a high AC voltage into a low AC voltage as shown in this figure. Now, efficiency of the transformer, eta is equal to output power over input power multiplied by 100. Eta is equal to VSIS over VPIP into 100. Note, for an ideal transformer, eta is equal to 100%. Since output power is equal to input power, generally in transformers, small energy losses will occur due to the following reason. Number 1, flux leakage. There is always some flux leakage, that is not all of the flux due to the primary passes through the secondary due to the poor design of the core or the air gap in the core. It can be reduced by winding the primary and the secondary coil one on the other. Then resistance of the winding. The wire used for the winding has some resistance, and so energy lost due to the heat produced in the wire opening I square R. It in high current, low voltage winding are minimized by using thick wire. Then eddy current losses. The alternating magnetic flux induces eddy currents in an iron core and causes heating. The effect is reduced by having a laminated core. Then hysteresis. The magnetization of the core is repeatedly reversed by the alternating magnetic field. The resulting expenditure of energy in the core appears as heat and is kept to a minimum by using magnetic material which has a low hysteresis loss. Now we have some MCQ type of questions on this transformer topic. Transformers are used in number 1, DC circuit only, number 2, AC circuit only, number 3, both AC and DC circuit, number 4, integrated circuits used in AC circuits only. The magnitude of the EMF across the secondary of the transformer does not depend on number 1, the number of turns in the primary, the number of turns in the secondary, the magnitude of the EMF applied across the primary, the resistance of the primary and the secondary. The correct answer is resistance of the primary and the secondary. The transformer ratio for an ideal transformer is Vs upon Vp is equal to Ns upon Np, Vp upon Vs is equal to Ns upon Np, and Vs upon Vp is equal to Ns upon Np is equal to Ip upon Is, or Vs upon Vp is equal to Ns upon Np is equal to Is upon Ip. The correct answer is Es upon Ep is equal to Ns upon Np is equal to Ip upon Is, as we have just studied. Thank you.